Now, on the whiteboard beside us, we can actually see our specifications for this particular engine. Our limit, though, is what we care about, 2.6063 inches. Anything bigger than that, we're going to have to oversize this. Now, that being said, our specifications, you can see 2.5996. We go greater than thousandths of an inch, we actually take it to the 10,000ths of an inch range. Now, while this is a really nice tool, it doesn't accurately measure to that range. So it's not useful for this particular situation. What tool does measure in that range is micrometer, right? Because it has our thousandths of an inch on here, 10,000ths of an inch on the vernier scale. So our micrometer is the guy. Now you can measure these a few different ways. Okay. You can select the correct size T gauge, and we're going to measure it. Now when we measure these cylinders, we have to measure several locations. Okay. I want to know what my maximum diameter is on the piston. Okay, is it within this limit? I also want to measure the out of round. Okay, and the out of round is what's the distance here compared to the distance here? Is it still round? Not a bad idea to actually check in 3 locations to get the best possible idea of what's going on here. So we can use this guy here to do that. You pop him down the hole and use it like a T gauge, pull it up through. When you're dealing with a cylinder, it's really nice to get a measurement of the taper as well. So take a measurement at the top of travel, the middle of travel, and the bottom of travel for that piston. You're going to have more wear at the top. We're also, well, it's not indicated here, it's going to have a taper limit as well. And that taper limit's usually around 2 thou. Engine manufacturer dependent. So we do have to take a number of measurements, right? 3, 6, 9, 18 if you add both cylinders. If you're doing an inline 6 or a V8, that's a lot of T gauge use. Okay, so it's not super efficient. It's going to take you all day to do that. They make another really handy tool called the dial bore gauge. It has a dial on it, and it has a little mechanism on the bottom that works like a dial indicator. It has a little prong here. When you push that prong, it gives you a reading. This here tool can easily be inserted in that bore, and you can measure that way. Works really quick. You can take 3 measurements, 1 second each, just about. So we're going to use the dial bore gauge to take these measurements. When we set the dial bore gauge up, you have to set it to a very precise measurement. This here does read tens of thousands of an inch. Okay, we have to set it to a very precise measurement. You can do one of 2 things. You can set it to the new measurement and run it. And when it gives you a reading, you have to add that number to your original spec. So you'll actually zero this so that the needle on the dial, if we ever get into focus, the needle on the dial goes to 0 at this particular measurement. Any flex on here, you're adding that to it. So you know how much you have to do a little bit of math, but you know how much your cylinder is going to be worn greater than new. Because we have a range, that's not very accurate. What if I set it to here and we have 10 thou of play? Is it this or is it this? So it makes a bit of a difference. In this case where we have an absolute limit, I'm going to set the dial bore gauge to the absolute limit, and then any deviation on that needle is going to mean we're under that specification. So let's take a look. Okay, I've stuck our dial bore gauge in the hole. Now what's going to happen here is I set the 0 to our absolute limit. That means this is set to 2.6063 inches. I'm going to arc the tool back and forth through an arc. In this case here, we have 2 supporting wheels. We don't have to worry about going back and forth. It's always going to find our maximum diameter. We just have to arc it like this to find the perfect sweet spot up and down. As we do that, I've set this here needle to the 0 on the dial indicator. Just the way it's set up, a little bit awkward, the 0's on the bottom. I do like it at the top, but what do you do? As I arc this tool up, okay, it's up like this. As I bring it down, right there where it stops moving is straight ahead. If I keep going, the needle comes back, indicating that it's a greater diameter. Whenever you use these, you sweep it until you find our sweet spot right here. In this case, if this is our 0, anything on this side is thousandths of an inch or 10,000ths of an inch in this case that we have to subtract from our maximum number. Anything on this side, we have to add to our maximum number. So if we ever see that needle here, when it stops moving on this side of the 0, we're above our limit. Anything on the side where it's at now, right here, is below our limit, which is what we want to see. It means we're within spec. So when I do this, I'm going to take some measurements right here, and right here in 3 spots. Then I'm going to drop it down, take some measurements here, here, and here. Go to the bottom, here, here, and here. Hard to see all of them on the camera though, as I'm going to be turning the tool. I can then move to our second cylinder, it has the same specifications, and I can take all of these measurements incredibly quickly.